Hey everybody, welcome to Lesson 5.2, Multiplying and Dividing Rational Expressions. Today we're going to shift gears towards, move away from talking about inverse variation, which is a type of rational expression, into actually simplifying them. So our objectives today are to simplify rational expressions and to multiply and divide rational expressions, and I'll divide that up into two videos. Okay, so the big thing here is the Common Core standard. Basically means you understand that rational expressions are closed under addition, subtraction, multiplication, and division by a non-zero rational expressions. What it means is that if closed under additions, it means if I add two rational expressions together, I'm going to get a rational expression. So for like integers, if you add two integers together, adding integers is closed under addition because when I add two integers together, I get an integer answer. Okay, that's what it means to be closed. So let's get into this. So a rational expression is a quotient, so a quotient of two polynomials. So go ahead and you fill that in. It's a quotient, so it's a fraction, quotient, okay, of two polys. And I'm going to run out of room, but I'll put it down here, polynomials, okay? And so we have several examples that I'm going to show you. And so something like, if you've seen this before, you have x squared, you know, there's a polynomial, and you're going to divide it by another polynomial. So maybe like x plus 2. And what happens if we had maybe just a number, 10 over x squared minus 6? These are all polynomials, okay? And the final, if we had like x plus 3, okay, over x minus 7. So those are types of rational expressions, the quotient, the division of two polynomial expressions, okay? Now it's important to realize here, because rational expressions are ratios, fractions, okay, of polynomials, we can simplify them the same way we do with other fractions. So if we had 9/24, okay, simplify 9/24, hopefully you see that 3, I'm going to move me down here, 3 goes into both of those, okay? So when I look at this, I could say, oh, 3 goes into 9 3 times, and 3 goes into 24 8 times. So 9/24 reduces to 3/8, okay? And what they're saying here is that because we follow the rational ratios of the polynomials, we simplify them the same way as we do fractions. It can be a little more challenging. So let's look at some examples. So example 1, simplify each of the expressions below and identify x values for which the expression is undefined. Well, you are undefined in a fraction. You're undefined in a fraction if your denominator, okay, if your denominator is 0. So that first one, can 2x, I don't know why it's not highlighting, can 2x to the fourth be 0? Okay, can that be 0? And the answer is yes, x here. And if I put it down here, x cannot be 0, okay? Because if you plug 2 times 0 to the fourth, you get 0 in the denominator. Can't have that. So let's look at how we simplify this. Well, we have 3 over 2. Well, 2 does not go into 3, so we're going to leave that. And remember, when you divide exponents that have the same base, we have two numbers with the same base, you subtract the exponents. So we're going to have an x here, and we're going to take that, and it's going to be 7 minus 4, right? And so then our simplified answer is just 3/2 x cubed. That's simplified, okay? So we simplified the expression, and we told them what x can't be. So in example 2, we have 16x to the 11th divided by 8x squared. That's a rational expression that we're talking about. And we see that 16 divided by 8, okay, that's going to be 2, so that reduces, right? You can go ahead and reduce that. I think this is an image. I don't know if I can write over it. We'll see. Nope. 16 divided by 8 is 2, and then you notice we have the two variables with the same base of x, so you're going to subtract the exponents, and so you're left with 2x to the 9th, and just like the previous example, x cannot be 0. You can't get 0 in the denominator, okay? So that's example 1. I'm going to go ahead and pause right there. and make a second example for example 2, because I don't want to run this video too long. So if you have any questions or comments on example 1, let me know. If not, move on to example 2, and we'll see you next time.